Good afternoon, ladies and gentlemen of Precalculus. Good to have you here today.
Good morning, everybody.
Good morning, as Hannah said. We always point out that it's morning in California. So anyway, and it's morning in Utah and in Colorado and in New Mexico. And even Mountain Time Zone too. Okay, so now exercise 31 through 24, the sequences are arithmetic. Find the common difference, the 10th term, a recursive rule for the nth term, an explicit rule for the nth term. And this first one here, I'm going to show you, we're going to go over part A. We're going to do that first. And then secondly, we're going to go down to part D. And then we're going to use part D to work out what part B is. So in that order. And I'm going to, just for this instance, show you a recursive rule just for an example. But as far as what I want you to do subsequently after this problem is to work on parts A, B, and D. A first, D second, and B third. So the common difference is, what number do you add to each successive number to get to the next?
Plus 4.
So it's going to be plus 4. And so our common difference, I'm going to put down A, the answer to A is going to be, the way you write this and articulate this properly is you write this out as D is equal to 4. Does that make sense? So that's part A. Now for part D, what we're going to do is go to our formula chart here, and we have this nth term of an arithmetic sequence formula, and we talked about that before, didn't we?
Yeah.
So now we use that formula, and this is going to be part D. We have A sub n is equal to A sub 1, and what is A sub 1?
6.
It's going to be 6. So we have 6 plus D, and what is D? 4 times n minus 1. So that is part D worked out. Does that make sense? Okay, now for part B, we're going to use this formula or rule in part D. We're going to call it A sub 10 is equal to 6 plus 4 times 10 minus 1. And what is 10 minus 1?
9.
So we have 9 times 4, which is 36 plus 6 is 42. And so that would be part D. And just for demonstration purposes on this problem alone, I want to show you what a recursive rule looks like. A recursive rule looks like A sub n minus 1 plus our common difference of 4 equals A sub n, and comma A sub 1 equals 6. And so you can start somewhere, and if you take a term and add 4 to it, you get its next highest term. So that's just what it looks like. I just want you to file that in your memory a little bit, but what I'm really interested in here are doing parts A, D, and B in that order. So what I want to do is call on somebody to do problem 22 here in about a minute. How's that? Can you do that? You can write it down. And I think we worked out some problems yesterday using this similar terminology to part C a little bit, I think. But we're getting close to test taking time, so I really want to focus in on, and plus we have to get through a lot of stuff too. All right? So let's go to the next one here. Yeah, 10 is just part of the instructions in the instruction set, that's all. And if you see problems like 25 through 28, we're going to use 8 for those instead. But Let's go to choose someone for this. Let's just shuffle here. And, okay, we got you first one today.
Did we have to find C?
No, you don't have to find C.
A is D equals 5.
So D equals 5, okay?
And D is A equals -4 plus 5 times A minus
Okay, and this is what Kaylee just told me what to do, okay? And then part B, finally, you had,
1.
so we put A sub 10 is equal to
4 plus
5 times, 40, you said? 41? Okay. Any questions about number 22? Okay, what I want you to do is go ahead and work out 23. I'll choose somebody else to do 23 here in short order. Okay. Let's go to number 23. Oh, 23, that's yours, Kenzie.
A, we got D equals 3.
So I'm going to put down for A, D is equal to 3.
And then we got a D, we had A, put the N equals -5 plus 3, parentheses, N minus 1.
Parentheses, N minus 1. Okay, and now we're circling back to part B now. Okay, Kenzie, what do you got for that?
A with the 10 equals -5 plus 3, parentheses, 10 minus 1 equals 22.
And what do you say it equals?
22.
22. Okay, I want to tell you something too, that the way you say this is A sub 10. Why do you call it sub?
Because it's substitute.
No, because the 10 is in what we call the place of a subscript.
That makes sense.
So if you use it as a subscript, so A sub 10. So that's what that is. Okay, thank you, Kenzie, good work. Go ahead and do 24, and I'll choose somebody to do 24 for us here in half a minute. Okay, next. So for 20, now, so Adam, he's out.
I'm going.
He's out.
I'll do it.
So no, here's what we do is I'll go ahead and choose somebody else. Adam will get his chance again later, maybe. From your mouth to God's ears, right?
Yeah.
The angel was begging, angel was said, he'll do it. All right, angel, you got it.
All right, this is number 24.
Yes.
D equals plus 11.
So D equals 11. Okay, part D.
A sub M equals -7 plus 11. 10 minus 1.
-7 plus 11 time
10 minus 1.
n minus 1, right? Okay, and then part B.
92.
Part B is going to be A, he says 92, so A sub 10.
Yeah.
It's going to be negative 7 times 11 times n minus 1, so that's going to be 9, right? And that's going to be 99 minus 7.
Negative 7 plus 11.
Oh, big plus, excuse me, yep. Let's get that right. We don't want to get things wrong here, do we? There we go. That looks better, right? Oh, 92.
92.
All right, 92, that's it, right? All right, thank you. Okay, we have the next set here is of geometric sequences. And what I want to do is kind of go through similarly to how I did 21.
Is it a different formula? Or is it-
So Hannah asked you a question.
I didn't score a single thing.
Okay, Hannah just asked a really good question, and that was, is this the same formula? That's the right question to ask. I'm glad she asked the question, because that way I just didn't have to come out and say it. So let's talk about this. Is the answer to Hannah's question is what? Yes, it is a different formula. And that's a different formula. So here it is, a sub n equals a sub 1 times r to the power of n minus 1. All right? So for part A, our common ratio is what we multiply by each term to get to its successive higher term. So here we have, it'll be times 3. And we see that applies for each of these multiplications. So we articulate it thusly. We say r is equal to 3, which stands for a common ratio. And now for part D, what we do is we say a sub n is equal to our initial value. What is our initial value? 2 times r, and r is equal to 3 to the power of n minus 1. And now for part B, what we're going to do is we're going to find it says the 8th term is what we're looking for. In this case, we put a sub 8 is equal to 2 times 3 to the power of 8 minus 1, which is going to be to the power of 7. So it'll be 2 times 3 to the power of 7. So 2 times 3 to the power of 7, we get this, 4373. 4374, thank you. 4374. So one thing I don't like about the exercise set in 21 through 24, what do you notice about 21 through 24? I know I'm kind of scattering around. What do you notice in 21 to 24? Well, I'll tell you. What happens is, in 21 through 24, they have D be a positive number. But do you realize that D could possibly be a negative number, and you could go down instead? So just be ready for that. Since I remembered, I wanted to mention that. So here we are back at 25. You have any questions about 25 and the use of that formula and where to find it in your formula chart? No? You're good? What I'm going to do is call on somebody to do problem 26 here in just another minute or so. Okay. So anyway, let's see who we have for problem 26. Looks like it's going to be Good Morning Hannah. All right, what do we have here?
So I got A is equal to 2, which I'm doing.
What is equal to 2?
A, number D.
R
Oh,
is equal to 2. Okay, that's another thing. Okay, the vocabulary, the common ratio we have by convention is R. Does that make sense? R representing ratio. And common difference is D. Okay? Go ahead, Hannah.
B, I got a n equals 3 times 2 to the n plus 1.
Okay?
And B, I got a 8 equals 3 times 2 to the a plus 1. And I got 384.
384?
Yeah, that's right.
Okay. Okay, makes sense. So why don't you go ahead and do problem 27?
Yes.
Okay, problem 27, we have, we'll see. It's going to be Carmen. All right, Carmen. What do we have here, Carmen?
Just tell me. Please, tell them what you have.
So what is your R equal to?
She has R equal to -2.
Okay,
Yes, she do, just say it.
all right. And now part D, we have A sub n is equal to, what's our initial value? 1
And then she has -2 in parentheses, and then she has n minus 1.
times -2 to the n minus 1, okay?
For B, she has a, wait, how are you gonna say it? Sub A equals 1 parentheses -2, and then she has a minus 1 equals -128.
To the 8 minus 1 equals 128, negative 128, okay? So what do these equations remind you of in 25, 26, and 27? What does it remind you? Remind you anything we did in class recently? Should. What kind of equation or expression does that remind you of that we did? Remind you of what?
Interest.
Reminds you of interest, right? Which is what kind of function?
Exponential.
It's an exponential function. So these are exponential functions like initial value, right? Remember initial value and base. Okay, good. Let's go on to 28.
Are we doing the back?
I'll tell you, I think we will do most of it. You know, okay, 28. Okay, we got Emily. Emily's got 28. All right.
Remember A, R equals -1.
R is equal to -1, okay?
B, A,
So
A,
then,
yeah, equals -2 times -1 divided by
okay. B, we have That's going to be -2. Sure it's going to be -2?
I got 2.
I got 2.
Let me tell you why I think it has to be 2. Okay, look at this is just alternating, right? First term, second, third, fourth. What is the pattern? Yeah, one thing you got to be careful about in the calculator when these things is putting these things inside parentheses here, because if you don't, you could get tricked. Just watch out for that. All right. Okay, we're going to get on to the next set here. And the next set, okay, what happens is, in the next set, we sort of have to work backwards a little bit. And in 29 and 30 were, I'll just show you what it looks like. The way I like, there are alternative ways to set these up, but what I like to do is construct a table, kind of like this, and I'm going to put n here and a sub n over here, and I'm going to put, we have the 4th and 7th terms, so I'm going to put 4 here and 7 here, and the 4th term is going to be -8, and then the 7th term is going to be 4, and so that's kind of what it looks like. So the first thing I would do here is try to find our common difference. How would you find your common difference? Yeah, I'd subtract both sides. So 7 minus 4 is 3. 4 minus -8 is 12. So our common difference is going to be 12 divided by 3, which is 4. So that's going to be our common difference. And now, and by the way, on these things right here, I want to go ahead and find the explicit rule. I just think that's more helpful for the nth term. Okay, and it says now we found that. How do we find everything else here? We want to find the first term. How do we find our first term? Okay, so a sub 1 is equal to, well, our first term. We have to go find out where our first term is, don't we? So if you continue going the other way, I think Angel did it. If you go ahead and subtract 4, you get, this one's going to be -12, right? And for 2, you're going to get -16. And for 1, you're going to get -20. And so a sub n, our explicit rule, is going to be -20 plus 4 times n minus 1. So this is our explicit rule. So we can use that rule to find anything. What does this equation here and the process of working it out remind you of? Should remind you of, for most of you, 8th grade algebra 1. It was, yeah, so it was a long, long time ago, but there's a song we sing in this class that talks about a long, long time ago. Right? And does this have to do with that? It does. Right? So what kind of relation is this? So this is a linear type of relationship, isn't it? And if we made this, now this is discrete math, And by discrete math, we mean that we're only talking about as inputs whole counting numbers, right? 1, 2, 3, 4, 5, 6. So we don't have those things, so that's why we call it discrete. And if we were to graph these and plot, what would the graph of these look like?
Linear.
They would be linear in pattern, but what would the actual graph of it look like? No, they will be individual points, right? That's discrete data is individual points. Continuous data would be actually the points connected. All right, so we have, that's as far as I want to go on this one. Let's go to, I'll choose somebody for number 30. So here we go, number 30. And we are going to have Emma for number 30. All right, Emma. What do we got? Let me see what you have. So did you draw a table? She didn't draw a table. Let's see what you have. Oh, so you drew a really short table. Okay, I'm just going to draw what she has here. So she drew a little short table like this, and she put A sub n here, and A sub n, and she put 5 and 9, and then -5 and -17. Go ahead. So 4, 12. So D is equal to? D is equal to -12 over 4 is equal to -3. Okay, so now we have D. What's next?
I got 22.
Seven, right?
So you could add, couldn't you? Like a certain, go ahead. Did you find A sub 1? Is that right, Emma? So 7?
Yeah, I see. Yeah.
And so what is our explicit rule going to be when we're going explicit? So A sub n is going to be 7 plus -3 times n minus 1, okay? And sometimes you'll see this just as a 7 minus 3 times that also, right? Which would be the same thing. So that'll be that. Now what I want to do is I want to show you 31, because 31 and 32 are like the same sort of concept, but using a geometric sequence. I want to show you what that looks like.
So you divide instead of subtracting?
Yeah, so you divide instead of subtract. So the Angel's right about that. So let's go take a look. So go here to 31. It says the second and eighth term. So I'm going to do the same type of arrangement as before. I'm going to have n and A sub n, and the second and eighth term. So 2 and 8, they're going to be 3 and 192 respectively. And we are told that we are geometric, and it does, in this instance, give you an explicit rule instruction. So how do you figure that out? And it's similar to something we did way back when we were working on what kind of functions. Okay, so here we went up 6 times on the left, but how do we articulate this on the right? What did we multiply by 3 to get 192?
64.
So 192 divided by 3 is going to be equal to 64. So how do we find out what R is?
Divide 2.
Well, R, we don't know what R is, but we know that R to the power of 6 is equal to 64. And now how do we find out what R is?
The 6th root.
R is going to be equal to the 6th root of 64. And what else?
2.
What else that we talked about when we worked over exponential functions? What else? Plus or minus, you say? Yes, okay, they got plus or minus. Good. She's the first one of the day to get credit for that. And so we worked that out. R is going to be equal to plus or minus 2. And now we can write out our explicit formula, which is A sub n equals A sub 1. Well, A sub 1 is just going to be 1, right? Because we divide by 3, 1, 3. So 1 times plus or minus 2 to the power of n minus 1. And sometimes I've seen this written as the plus or minus kind of written out front. I like to write it like this because it shows that it could be either plus or minus and get you to the same place. Okay? So that is going to be 31. This one here is a similar type of problem, but I don't want to spend the time on that because I want to start on something else today. So you can turn in this paper here today, and we're just going to barely get started on this next one here. Okay?
What? That was when you told me. Okay. She's gonna see what she needs. Come on.
Okay, now we are to here. And what I want to do is just, on these first 4 ones here, you could graph the sequences and basically you'll get dots, like I talked about earlier, when you graph these. So I'm just, in the interest of time, going to skip over these first 4 and get to this problem 37. So rainforest growth, bunchy tree in the Amazon rainforest grows an average of 2.3 centimeters per week. write a sequence that represents the weekly height of a bungee tree over the course of 1 year, 7 meters tall today. Display the first 4 terms and the last 2 terms. How would you go about this? What is D going to be?
2.3.
D is going to equal 2.3, and also, Angel, you're right, except also centimeters. All right? What is going to be A sub 1?
700.
700 centimeters. Okay, and so we'll cut that, because that's what happens. You have a conflict of units. So you might have to sort that out in your mind. So if you're open-minded so as to be thinking about that, you're good. And so now it says display the first 4 terms and the last 2 terms. So the first 4 terms, we know A sub 1 is already 700 centimeters. And what's A sub 2 going to be? 2.3 centimeters. And A sub 3 is going to be, so 4.6 centimeters. And A sub 4, 706.9 centimeters. And now it says the last 2 terms. Now how could we get the last 2 terms? We could continue adding, right? But class needs to end here in the next few minutes, right? Do we have time to add another, I don't know how many weeks till the end of the year? No. So what are we going to do instead? We're going to write a formula here. A sub n is equal to 700 times what? Plus what? 2.3 times n minus 1. And so now we can find A sub 51, right? Because that's the last 2 terms. So what is A sub 51? 700 plus 2.3 times 51 minus 1. So we have 700 plus 2.3 times 50. And I think I did that in the last class. So 815 centimeters. And what's the very last we could, what's going to be A sub 52?
That'll be 817.3.
817.3. And you just added, right, to the very last week to get that. So that's as far as I want to go on this today. So just hold on your paper, and we're going to actually merge into sequences, our series, tomorrow. And actually, yeah, so what we're going to do tomorrow is we're going to just go to problem 39. That is it. Yeah, so I can go back. Right here. Okay.